Hi everyone. We have a number theory question which says how many positive two-digit integers are factors of 2 to the power 24 minus 1. Now the expression is 2 to the power 24 minus 1 and we need to find the factors such that these factors are positive two-digit integers. So when you say positive integers, we're talking about natural numbers themselves, right? So we're talking about two-digit natural numbers factors of this original expression. So let's write down the expression itself, 2 to the power 24 minus 1. Now, what comes to our mind when we look at this expression? Of course, this is not a very friendly expression to be handled with respect to finding factors, right? So, what comes to our mind? Can we think of it as a square minus b squared as an analogy? Because 2's power is even and we can assume 1's power as also even. So, if I break it down such that it's an a squared minus b squared into product of factors, I can write it down as a minus b multiplied a plus b, which can be written down as 2 to the power 12 plus 1 multiplied 2 to the power 12 minus 1. Now this second expression can further be broken down on the similar lines, right? So I can write this down. So the first expression is as is. The second one can be broken down as 2 to the power 6 plus 1 multiplied 2 to the power 6 minus 1, right? And the last expression again can be further simplified on the similar lines. So I can write down the entire expression as 2 to the power 12 plus 1 multiplied 2 to the power 6 plus 1 multiplied 2 to the power 3 plus 1 this time and multiplied 2 to the power 3 minus 1. Now if you look at the last three factors of this number, these three are pretty easy in calculation and we can literally jot them down straight away. So I'm just repeating the first expression which further needs to be simplified. And then the next one is 2 to the power 6, 64 plus 1, 65. 65 multiplied 2 cube is 8 plus 1, 9. Multiplied 9, 2 cube is 8 minus 1, 7. Okay, now what about the first expression? If you look at this expression, now 12 is a multiple of 3. So can I imagine this as a cube plus b cube? This expression as a cube plus b cube, where a is nothing but 2 to the power 4. So a cube is 2 to the power 12 and 1 is b is equal to 1, right? So, and I know that a cube plus b cube can be factorized as a plus b multiplied a squared minus ab plus b squared. So using this, can I write this as a plus b, which is 2 to the power 4 plus 1, multiplied a square, which is 2 to the power 8, minus ab, which is 2 to the power 4, plus b square, which is 1. And 65 can be broken as prime factors as 5 into 13. And 9 is, of course, 3 squared, and 7 is 7. Now 2 to the power 4 is 16 plus 1, 17, multiplied 2 to the power 8 is 256, minus 16 is 240 plus 1, 241. Multiplied 5 into 7 into 13 into 3 squared. Okay, now we have basically broken down the original expression, which is a natural number itself, into decomposition. We have decomposed it into its prime factors and its powers and their powers. So now, getting back to the crux of the question, how many positive two-digit integers, so how many natural number two-digit factors of this expression are there? So what do we do from here? So let's try and look at individual contributions of prime factors and what can they be paired up with in order to become a factor of this original expression. So let's start with the biggest number here, which is largest number here, which is 241. So 241, if you think, is already a three-digit number. We are looking at a two-digit factor, right? So no matter which other factor I pair it up with, it will still be a three-digit number. So 241 is out of consideration, right? We don't need that into consideration. Okay, the next one in line is 17, the second largest prime factor. Now, if you look at 17, what can I pair the 17 with? I can have 17 into 1, which is a two-digit factor, positive factor. I can have 17 into 3, which is 51. Can I have 17 into 5? Yes. 17 into 5 is 85. Okay. Can I have 17 into 3 squared, which is 9? No, because now it will, the product will go into the 3-digit number, which we do not want. And of course, 17 into 7 is also a 3-digit number. So basically we stop here. This is the highest possible. 17 into 5 is 85. So essentially we can say that we have 3 factors which are 2-digit positive factors of the original expression, which contain 17 in them, right? Okay, let's look at the next largest number, which is 13. So 13 into 1 is possible, 13 into 3 is possible, 13 into 5 is possible, 13 into 7 is possible, 13 7 is 91. 13 into 3 squared is not possible, and no other combination thereof. 3 into 7, 3 into 5 is not possible. All of them will be 3-digit numbers then, or 4-digit numbers. So all in all, we have 4 factors coming in from here, 4 2-digit factors such that 13 is contained in them. Okay, the next one is, let's say, next one is 7. So can I have 1? I cannot, because 7 into 1 is a 1-digit number. We need 2-digit number. So 7 into 3 is the minimum. Then 7 into 5 is a possibility. 7 into 3 squared is a possibility. Do we have anything else? There is only one power of 7, so I cannot multiply it with 7 again. So 7 into 15 is not possible. 7 into 35 is not possible. So on and so forth. So the only possibilities, so 7 into 9 is the maximum that we can derive out of here. So 3 factors again from here, such that 3 2-digit positive integers are factors of this original expression containing 7. Okay, the next one in line is 5. So 5 can be multiplied by, now we should not consider 7, 13, 17 because already covered, right? So we should not include 17, 13, 7, 241, all these, because we have already covered them. We do not need to repeat them again, right? So 5 can be combined with, cannot be combined with 1, right? So we will have to start with 3, because 1 will give you 1-digit number. 5 into 3 is possible. 5 into 3 squared is possible. And then we are done, because we can't use 17. We cannot use 7, 13, 17 and all. So basically we get 2 factors from here. Now the next one in line is 3. But if you look carefully, we have already exhausted all the possibilities where 3 could be used, right? So you have all the multiples of 3 already included, be it the other prime factors 5, 7, 13, 17, etc., or the powers of 3 themselves. So essentially, now the next step left is only to simply sum these factors up. So if you sum them up, 3 plus 4 plus 3 plus 2, which is 3 plus 4, 7 plus 3, 10 plus 2, 12. Now, this is the number of factors. So 12 factors which are natural number 2-digit factors of the original expression 2 to the power 24 minus 1. So the correct answer to this question is choice D. Thank you.